Hello there. I'm back to continue the build of this B2-EMO Pro mechanical head mechanism. Previously, I got the lower part built. I've fitted a couple of the servos now, and I'll fit the third servo and show that one being fitted. One thing I never pointed out previously was that on these aluminium machine parts, 4 screw holes need tapped as M2, M4, and one in the back requires tapping as an M3. There's a further 2 down the side here, which they can be tapped as M3 and used as cable management points, but they're not required for the build. So those have been tapped on all of these. So moving on, the servo that we're using in this build is a Reefs RC 1000 Smart, aluminium bodied, fully programmable servo, quite high end, and I've never used them before, but feel very, very robust. Okay, and on the front of this, we will be fitting a round horn, round metal horn with M3 clearance holes. So what we want to do is just roughly set this up using a servo tester. Plug this in. Grey is the data line, and then plug a power supply in. So you can see, it moves there, and we'll put it to the central position. And what we want is, when this is mounted horizontally, this disc to have one hole at about the 11 o'clock position. So if that's 12 o'clock, about 11 o'clock position, that means that when we have full rotation from one end to the other, that will give the full lift of the mechanism. So we press that on. So there's some holes cut in the aluminium here as well, which we can feed cables through. Keeps the cables clear of the mechanism. And then these are mounted with M4 by 6mm button head screws. Obviously 4 of them. Okay, so next we will be fitting one of these machined aluminium arms. Obviously it's got the 5 screw holes to attach with the horn, and then on the other side there's a hole which is a second pivot point on the other side. These require a flanged ball bearing, 6mm ID, 14mm OD, and 5mm thickness. These are, because these are machine parts, it's a very tight fit, so I've had to actually press those into place. I'll do that one afterwards, but I've done this one. And then what we have is some screw parts. these out. Okay, and there's one more part I need to find. The last part we need for this single pivot point is a 4mm by 6mm by 1mm plastic spacer. So very simply, this dry running flanged sleeve bearing pops on the outside here, and the shoulder screw. These are both McMaster car parts, which will be on the bill of materials. They pop together like so. This plastic spacer on the inside. You'll have to be careful when you're actually screwing in that this spacer is correctly seated and has not been pinched. So it has to be up against the metalwork like so. But to get the screw in, you need to pull it back, and that allows the spacer to move around a bit. To help me get that spacer out of the way, I'll just use the blunt back of a blade just to help nudge it around. There we go. You can feel whether or not it's binding or not. Okay, and then on the other side, we've got 5 screw holes. There's an M3 by 12mm countersunk on the center, and then the 4 surrounding ones are M3 by 6 countersunk screws. Pull these screws in very quickly. And just testing again that we've got the mechanism centered correctly. When the servo is centered, that's roughly where the arm should be sitting, and then we can take it to maximum, and we can just about to touch against the metalwork there, and going up, there we go. So that's the full movement. Some tuning will be done of these servos at a later date. So I'll fit the last one later. Moving on, we have the Go Builder speed controller. This is the speed controller which will take the transmitter signal for the head rotation and translate it into the power for the motor. So for this, using a couple of M4 by 22 socket screws. Put that away. There's a couple of spacers. These are 4mm ID spacers, so they fit over the screws, and 7mm length. So what they do is they attach onto these Go Builder sort of right angle connectors. We have 2 of those. And then we have a further 2 button head M4 screws, 16mm length, which will go through the speed controller into these mounts. So this is where we're going to be mounting it. So if we rotate this, we have the opening here. We can rotate it, and we can get access to both of the screw positions from underneath. So this just comes up. I think I've got a slight alignment issue with the plastic. Get this through. Maybe those clearance holes just have a slight burr on them. Yep, slight burr, just stopping them from going through properly. Just really need to get them started and then push up. So you've got the 2 screws, 2 spacers, and then taking the adapter. You've got a hole in one side, and then you've got a through hole. So if we take that through hole, connect. I'm not tighten it too tight at the moment. Again, taking the through hole here. And then okay, get the definite feeling. I would have been better attaching. Yep, would have been better mounting these blocks to the motor driver before screwing them down here. So let's pop them off again for a second. Okay, try again. So 2 screw holes here, and there, and we will there's the wrong hole there. For these mounts, we want to use the hole which is not the through hole. And you can see there's a small chamfer at the top corner as well, which gives a bit of an indication which way up you are. vertical. Now we should be able to attach these nicely. And because this is a plastic enclosure, we don't want to put too much strain on it when we tighten these bolts at the front, but we do want to make sure they hold. So just go. So this will be the 24 volts in and the signal from the transmitter, and then this is the whatever the motor driver voltage is, and it will come over to this motor. Okay. The last thing to fit at the moment is the Castle CC BEC voltage regulator. This is going to be mounted in this position. What I've done previously is I have just glued in two of these Wago 221 connectors. So what we'll do is 24 volts will come up through the slip ring, positive to one of these connectors, negative to the other, and then the other two terminals, one will come up to the BEC, powering it, and the other terminal will go across to the speed controller, giving it its 24 volts. So that is the 24 volt distribution for the mechanism. On top of this, we have a cap piece, which is just held down with a number of M3x6 screws. And then the actual BEC itself. So I've fitted industrial strength Velcro here, and I'll tuck the power cables in underneath here. And once I've terminated the ends here, I'll be able to tuck those back down, connect them into these Wagos, and then this will screw down just here. But I won't do that at the moment until I've terminated those ends. So I'll finish this off, I'll fix this third arm in place, and then that is really, other than the wiring, the base assembly complete. Okay, I'll now continue with the assembly of the top part of the mechanical head mechanism. I'll put up a picture of the mechanism as I'm going to assemble it, so that you get an idea of the structure. But essentially, there's a universal joint attached to the bottom side of this, which will then have a sonic hub attached to the base of it, and a pin, 6mm diameter pin, which will slide down that bearinged tube in the base. That means that the head will always be central above the mechanism. So if I start putting this together now, using M4 by 6mm screws, and they're not the easiest to get into this. And this goes into the center. The way the CAD shows it, the solid part of this upper universal joint is facing the magnetic connector. Whether that has any significant clearance implications, I'm not sure, but I'm just going to build it as per the CAD. Okay, the Sonic Hub is a 6mm bore Go Builder part. And again, this is mounted using M4 by 6mm screws. You can see that this circular part will locate into the universal joint. And then again, we need to screw in from the underside, or the internal part of the UV joint. Then the 6mm pin, it should just go through to, it's very difficult to see, but just the depth of the Sonic Hub itself. So you thickness of the Sonic Hub, and then tighten these two side clamp bolts. Okay, so that will sit on the top of the mechanism. Underneath here, you then have three lifter mechanisms. So these will screw onto the plate, and the other end will go onto those servo lifter arms, moving up and down. So I've made two of these already, and I'll show you myself making the third one. So first of all, we have two of these two-post pillow blocks from Go Builder again. And we have a steel ball linkage. Again from Go Builder. Two 7mm length spacers. Need four of these plastic spacers, 6mm ID, 8mm OD, and 1mm thickness. Sorry, four of those. A shoulder screw. From an M4 washer, which is 0.25mm thick, and a 4mm washer, which is 1mm thick. And to go on the end of that, I need one M3 nylock. So taking your shoulder nut, first thing to do is put on the 0.25 thickness washer and one of these spacers. And then on these pillow blocks, you'll notice that on one side the bearing is flush, and the other side the bearing is inset. So what we're looking for is for the inset side to be external on this mechanism. So take your bolt and spacer, inset side and push it through. Then we fit 2 of these plastic spacers. Ball connector, spacer, and another 2 of these plastic spacers. Then remembering again to keep inset part of the bearing to the outside, and then we have the 1mm washer. Make sure that is aligned centrally there. Fingers and thumbs. Okay. M3 lock on the end. Then using a 5.5mm spanner just to tighten that up. Okay. So that's the first part of our mechanism. On these large machined parts, which are again from PCBWay, I believe, you do need to tap with an M4 just this one hole on it. The other 2 holes are clearance holes and they're already dimensioned. And then all we do is we just screw this on. There we go. And once we've got it through, we fit the M4 nylock on the other side just to lock it in place. And you obviously want all of these to be as close as possible to the same length. Three matched items. There we go. That's the third one. So these then are fitted to these countersunk holes here with these M4 by 8s, I think. Yep, M4 by 8s. So 4 on each of them. So I could probably do with a third hand. It's really just these first 2 screws that are tricky to get in. And it's almost aligned for you. Okay, so that's one mounted, and I will come and do the other two. I'll do the other two in a second. So there we go. That's the upper mechanical assembly. There's still magnets to go on here and a magnetic electrical connector, but overall, the mechanical assembly is relatively simple. I'm going to end part 2 here, as it's now just over 30 minutes long and there's still quite a bit to show. As I've built the 2 main assemblies, I think this is a good stopping point, and in part 3 I'll bring these together into the full assembly and show it working. I hope you're finding these videos useful, and join me for part 3. See you soon.